Okay, we're going to look at meteor strikes on Earth, meteors, comets, and asteroids that have left a crater behind that we've discovered. They're harder to spot on Earth because of weather and vegetation has worn them out, but hundreds have been discovered, and we now know the Earth has been pummeled in the past, just like the Moon was. We want to take these craters and put them on a map of our local area of Ontario so we get an idea of exactly how big they are. Each map comes with a scale, and so does CorelDRAW at the top of my page. So when I look at this map scale that represents 10 kilometers, I can see that it takes 18 millimeters on my actual paper. I've done this before, so I happen to know that that measurement is exactly 18 millimeters on your sheet of paper. So 10 kilometers in the real world on my sheet of paper is 18 millimeters. That's your first scale. So we now know how to convert between millimeters on the sheet of paper and what they represent on the real Earth that this is showing. Then there will be a different scale on this map because it's got a bigger view. Finally, we are going to attempt to take the size of these real craters in kilometers, and we'll use our scale to convert them to the size we should draw them on our sheet of paper. And to do that, we need to make a map scale. And the scale ratio looks scary, but it's common sense. We take the page distance we found in millimeters, and we take the known world distance in kilometers that the scale gave us, and we divide the two. In mathematical shorthand, we could write it like this. The scale ratio is distance on the page over distance in the real world. And it will make common sense, like a taxi cab driver. If he's charging you $1.20 per kilometer and you travel a distance of 50 kilometers, how can you calculate the total? Well, it's common sense, $1.20 per kilometer. So if you go 50 kilometers, you multiply. So how do we do the map scale for our first map? Well, what we're going to do is take those numbers and divide them. So I'm going to take the 18 millimeters that we measured on the scale, and I'm going to round it to 20 millimeters. And that distance we need to divide by what it really meant in the real world, which is 10 kilometers. And this gives us a map scale of 2 millimeters per kilometer. This means for every millimeter we move on the map, that's a kilometer in real life. So what does that allow us to do? This first crater then, if we want to travel 300 kilometers, and each kilometer is 2 millimeters, we take 300 kilometers, times it by 2, and we get 600 millimeters, which is the same as 60 centimeters. It cannot possibly fit on the first map. So you can't graph this one. But you go all the way down and see which ones you could fit on the one map. Then you get the map scale for the wide view and see which ones you could fit on the wider view on the map, and you will now be able to scale those craters to size. The tricky one is the Hellas Planitia crater on Mars isn't going to fit on either. So is there any way you can somehow fit it on one of those maps? So this is your assignment for today. Away you go.